Welcome to EDU World Space.
So in this video, we're going to talk about question 24 from chapter 20, which says write balanced equations describing the reaction of strontium with each of the following: O2, S, Cl2, P4, H2, H2O, and HCl. And I want to point out that all of this information is summarized in table 20.7. So if you need a summary, you can look there. But we can also figure it out ourselves just by knowing that strontium likes to react to lose 2 electrons to have its +2 charge to have the noble gas configuration. And then that ion is going to form ionic compounds. So when we have strontium plus O2, the ionic compound will be between strontium cations with a +2 charge and oxygen anions. Our oxygen usually takes a -2 charge. It likes to gain 2 electrons to reach the noble gas configuration. So we have +2 and -2. Our charges are balanced, but we need to balance the elements, the atoms in our equation. So on the left-hand side, we have 2 oxygen atoms, and the right-hand side, we have just 1. So we need a coefficient of 2. So we have 2 SRO, but now we have 2 strontium atoms on the right and just 1 on the left. So we also need a coefficient of 2 in front of our strontium. So the balanced chemical equation is 2Sr plus O2 yields 2SRO. Next, we have the reaction between strontium and sulfur, and this is actually really similar because oxygen and sulfur are from the same column or group of the periodic table. So we know that our strontium wants to form that +2 ions. We have strontium +2, and then sulfur also forms a -2 ion, just like oxygen does. So we have +2 and -2. Our charges are balanced. And our elements are actually balanced as well. So this equation is already balanced. So we have Sr plus S yields SRS. Next, we have the reaction of strontium with chlorine with Cl2. So again, our strontium is going to want to form that +2 ion. And then it's going to form an ionic compound with chloride ions. So the ion we form from chlorine is chloride with a -1 charge. It's one of our halides. So we have a -1 charge and a +2 charge, so we need 2 chlorides to balance that. So Sr plus Cl2 yields SrCl2. Next we have strontium plus P4. So this time we're forming a slightly more complicated ionic compound. So we know that our strontium is going to have a +2 charge, and then we have phosphorus. What charge does phosphorus usually take? Well, phosphorus likes to react to gain 3 electrons to reach the noble gas configuration, so it's going to have a -3 charge. So I have something with a +2 charge and something with a -3 charge. The least common multiple of 2 and 3 is 6, so I'm going to balance this as +6 and -6. So my +2, I need 3 of those to get to +6, and my -3, I need 2 of those to get to -6. So +6 and -6 is balanced, so I have Sr3P2. And we clearly need to do some balancing in this equation. So on the left-hand side in our reactants, I have 4 phosphorus atoms, and on the right-hand side in our products, I have 2 phosphorus atoms. So I'm going to put a coefficient of 2 in front of our strontium phosphide, our product there. And now I have the same number of phosphorus atoms on each side, but I still have a different number of strontium atoms. So in our products, I have 6 strontium atoms, and in our reactants, I have just 1. So I'm going to put a coefficient of 6 in front of strontium. And our balanced chemical equation is 6Sr plus P4 yields 2Sr3P2. And the next chemical equation we need to balance is for the reaction between strontium with hydrogen. So again, strontium is going to want to form that +2 ion and then form an ionic compound. And then hydrogen is going to act as the anion. It's going to form a hydride ion. So we have Sr plus 2, and then our hydride ion, H minus 1, has a -1 charge. So we need 2 of it to balance our +2 charge on strontium. So our balanced chemical equation is Sr plus H2 yields SrH2. The next reaction we need to balance is between strontium and water. So we have strontium plus H2O. So again, we're going to want to form an ionic compound, and we know our cation is going to be strontium plus 2. But what about our anion? So the easiest anion to form from water is hydroxide. You just remove a proton and then you have hydroxide. So hydroxide is OH and it has a -1 charge. So we have our strontium with a +2 charge and our hydroxide at the -1 charge. So we're going to need 2 of our hydroxides in order for that to be a neutral ionic compound. So we have SrOH2 is our product. So now we have 2 oxygen atoms on the right-hand side of our equation and just one of our on our left-hand side of our equation. So I'm going to put a coefficient of 2 in front of our water. And we have the same number of strontium atoms on both sides of the equation, so we don't need to worry about that. But I have 2 hydrogen atoms in my products, but 4 hydrogen atoms in my reactants. So I need 2 more hydrogen atoms. And I can't get that just by changing the coefficients on my current reactants and products. So what I'm going to do is I'm going to add H2 to my products. That's 2 more hydrogen atoms that should balance my equation. So the balanced chemical equation is Sr plus 2H2O yields SrOH2 plus H2. And the last chemical equation we need to balance is the reaction of strontium with HCl, with hydrochloric acid. So we know that strontium is going to react to form its +2 ion. So we have Sr plus 2. And then the anion that's going to combine with that is our chloride ions that we get from hydrochloric acid. So since chlorine takes a -1 charge and strontium has a +2 charge, this is SrCl2 in order to have balanced charges. And then the other product we're going to form is hydrogen gas. So now I have 2 hydrogen atoms on the right-hand side of the equation and 2 chlorine atoms on the right side of the equation, but only 1 hydrogen atom and 1 chlorine atom on the left. So I'm going to need a coefficient of 2 in front of HCl, in front of hydrochloric acid. So the balanced chemical equation here is Sr plus 2HCl yields SrCl2 plus H2.